Today we're going to go over a couple of story problems. Our first one right here is to write a linear model that represents the world record in minutes for the men's mile as a function of the number of years since 1960. Now this phrase right here, linear model, tells us that we are going to be able to use the equation for a line, which we have learned is this, y equals mx plus b, where m is our slope and b is our y-intercept. There are, of course, other forms. But if we can find our slope and find our y-intercept from the information given, then we're able to write the equation in this form as well. We're going to use a couple of different tools to do that, namely tables of values and graphs to be able to find those slopes and the y-intercepts. So here's our first piece of information. It says in 1960 the world record was 3.91 minutes. So I'm going to start a table of values here. And on the left, in the y spot, we're going to have our time for the world record. And on the right, we're going to have the years, and it was mentioned earlier that that's measured since 1960. So I'm going to add that to my label. Years since 1960. All right. 1960 is 0 years since 1960. So for this value, we have 0. For our time, it's 3.91 minutes right here. So I'm going to put 3.91 minutes, and we've got our first data point right there. Our second data point comes in 1980, says the world record was 3.81 minutes. So we're going to write 3.81, and 1980 was 20 years after 1960, so that gives us a value of 20 for our years since 1960. I'm going to graph both of these points. We've got our time on the y-axis and our years on the x-axis. At year 0, we were up at 3.91, so that gives us this first point. And at year 20, we went down to 3.81, so that's here. And we can see that our mile record time is dropping as we would expect for a world record. So we've got to find our slope in rise over run. We're going to put it in that fraction form. So rise over run. We're going to go down by 0.1 from 3.91 to 3.81. Since we're going down, that is a negative value. So that gives us negative 0.1. Our run goes from 0 to 20. So that is a value of 20. And it's going to the right, so that's positive. If we simplify this, we can turn it into 1 over 200 so that we don't have that decimal and the fraction mixed up together. Either way would be okay. I prefer it this way. All right, so now we have our slope. We can see that since we've numbered 1960 as year 0, that resulted in us having a y-intercept here. And we can put those values into our equation now since we have our y-intercept and our slope. So let's go ahead and put those in. We get y equals, and our slope we just calculated to be 1 over 200. And our x is there, plus our y-intercept, which we see is 3.91 right here. So we get 3.91, and we're done with our equation. The next portion of the question asks us to make a prediction using this. So that says, predict the record time in 2020. This question's extra interesting to me because this was written a while ago, and it is now 2020, so we could actually look up the world record time and see what our prediction is and how it matches with what it really ended up being. So we have y equals 1 over 200, and we need to put in a value for our year. 2020 is 60 years since 1960, so our value that we're going to put in for x is 60. So 1 over 200 times 60 plus 3.91. Multiplying this together, we get y equals 60 over 200 plus 3.91. Now I could continue to simplify this, but I'm going to put it into a decimal to match this. I made a little mistake here. That was a negative when we had our slope, and so we end up with negative 60. So we're going down. We get y equals, and if I do 60 divided by 200, that's 0.3, and negative divided by a positive will end up being negative 0.3. Plus 3.91. Adding those together, we get 3.61. All right, so there's our prediction. I looked it up just a little bit ago, and it turns out the record is actually 3.71. So it hasn't dropped as far as we might have predicted back in 1980, but we do see that it is going down as expected. So kind of interesting to me to see how close we ended up predicting with our linear model. Let's take a look at a second equation over here, a second story problem. For this one, we're going to do a little business right here with a band. We are designing a sticker to advertise for our band, and we want to take a look at the prices. So we see that the company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers right there. Our first task is to write an equation that represents the total cost of the stickers as a function of the number of stickers ordered. So if I was to do a table of values, I would have cost over here and the number of stickers over on the X side. And important that we note that we are measuring those number of stickers in thousands. So this first 1,000 stickers we will represent with a 1. All right, and I'm going to write that in our table of values. Our first 1,000 stickers cost us $225. Now I'm going to get some additional data points here by using the $80 for each additional 1,000 stickers. If I have 2,000 stickers, that goes up to $305 because I added 80 to this. And if I go up to 3,000 stickers, I'm going to add 80 again. And I go up to 385. We could put those in a graph. So at 1, we're here at 225, 1,000 stickers. At 2, we go up to 305. And at 3,000 stickers, we go up to 385. We could continue to go if we wish, but we can see on this graph that each step, each 1,000 stickers, we're going to go up by 80 and over by 1, representing 1,000. If you look at the table, you could actually see the 80 show up here and the 1 show up there, so we can see the rise and the run just from our table of values as well. All right, so if we're writing a linear model, again, that's y equals mx plus b. We just figured out our slope with our rise and our run. So we get y equals 80 over 1, or just 80, x plus. We need our y-intercept, and we're not given it for this question. We've got to go back to one step to here. We could either use our slope and go over 1, which puts us on the y-axis, and down 80. So that would be a value of 145. Or we could go back a step in our table of values by going back 1, and that would mean we'd have to subtract 80 to get 145 there. Either way, we recognize, hey, here's the picture of our y-intercept. Here is our y-intercept because we can see the 0 right there for the x. And we have our y-intercept at 145. All right. Let's answer our last question. It says, find the total cost of 9,000 stickers. So that is our x value. We have 9 because we're measuring again in thousands. So we get y equals 80 times 9 plus 145. 80 times 9 gives us 720. And we get y equals 720 plus 145, which is 865. The units on that is dollars, as we can see right here. And we are finished with our question. Thank you very much.